Welcome to the workshop component of Module 11, and here I'm going to walk you through in Excel doing linear regression and covering some of the main measures that we discussed in Lecture 1 and 2 and that will be in your assignment. And so if you remember from Lecture 1, we have these measures that I showed you in the PowerPoint slide of the regression. So if you remember the equation of the regression, y equals beta naught plus beta 1x, what we want to do first is calculate the regression coefficient beta 1. Remember, this is what we're really interested in. This is the amount that our dependent variable y changes given a 1 unit change in x. So there's this complicated looking formula there for beta 1. Then we want to calculate the y-intercept beta naught. And then once we have that, we can calculate the predicted value of y based on our regression line, and then the error, which is the difference between the actual value of y and what our regression predicted. So the formulas look kind of complicated. It's actually pretty straightforward in Excel. So you can see here I've highlighted what the actual data would look like on the left-hand side of the screen. And so you're going to have, here we have 20 patients in column A. I've just labeled them patient 1 through 20. They have a set amount of charges for their hospitalization, which is our dependent variable y. And then they have a set up length of stay, which is our independent variable x. And so the first thing you would want to do is well, first of all, what you would want to do is look at a chart. So it's very easy. If you just select these columns here, a variable y and x, go to the scatter plot, insert it, you can see very quickly looking at a scatter chart that there's clearly a linear relationship exists here, right? So that means that we're okay to do linear regression. So there are all these complicated formulas, right? The first thing to do, though, is all the formulas need the mean of y, which are the charges, and the mean of x, the averages, right? And I've referred to them here in this little table under O. This table that I'm highlighting is x bar mean, x bar mean and y bar mean, just because that's how they're referred to in the formulas. So if you remember calculating the average in Excel, let me do it here. What you want to type in, look at this formula cell, is equals average, and then you select this row. So let me just delete this and do it just so you see an example. So go to formulas up here. If you go to under auto sum, average will come up, and you can see this little average thing will come up. It says equals average in this function bar, and there'll be 2 parentheses, an open and close parentheses. You can click your cursor in there and then click on, drag it across the y charges, right? Going from B2 down to B21, hit average, bingo. Average charges $3,584.91. You do the exact same thing for length of stay. So here, average is typed into the formula bar, and then I've selected C2 through C21. Here I have these dollar signs in here. For C, I didn't really need to do that there. You always put the dollar signs into the formula here. You don't worry about doing that for the average. That's unnecessary, actually. Okay, so you've calculated the average of y, the average of x. The next thing, remember, in the formula for calculating the regression coefficient is you want to subtract the average of y from the actual value of y, and ditto for x. So this is what I'm doing here. I created these new columns, E and F, and so let me replicate that again for you here. So I'm inserting 2 columns here, making them a little bit wider for us to work with, calling it y minus y bar, x minus x bar. And so what I'm doing here is I'm taking the actual value of y, say equals, and go to where your actual value of y is, in this case B2, click in that cell, and I want to subtract the mean of y, which we calculated up here over in cell R1. And in this case, you actually do want to stick a dollar value in your sign, because when you do that, what it's telling Excel to do is to basically always reference that cell. When you copy the formula, which I'm going to do in a minute here, I'm going to copy this formula. Remember, you copy by pulling all the way down here. I'm going to copy the formula all along the column, and so that's doing what I just did, is what you would do to copy. And because you put the dollar signs in R, what it's telling the formula to do is to always subtract the mean value in R1 from each individual observation. So you can see here the next y minus y bar is equal to B3 minus R1 and B4 minus R1. So you're doing that to get y minus y bar. You want to do the same thing to get x minus x bar. So you're just you're clicking in the x value for that individual observation, subtracting the x bar, which is the mean that you've calculated over here. Throw in those dollar signs to hold the formula on R2, and then you copy the formula down. You do that by grabbing the corner, and this little x comes up, and pulling it all the way down. And there you got your x minus x bar. Let me show you one other way that you could calculate the formula. So you can calculate the formula by clicking on that cell, hitting Control C, which means copy, and then selecting all those other cells you want to copy to, and doing a paste special. This little box will come up for paste special, and you want to click on formulas, and it will paste the formulas down there. That's another way of doing it if you don't like grabbing the cell with your mouse. In any case, you can see we've calculated y minus y bar and x minus x bar. So remember, the next step in the formula is to multiply. You just want to take this one step at a time. It seems like a lot, but you break it down one step at a time. It's tedious and monotonous, but doable. So you might think that about statistics generally. Anyway, so the next step in the formula, this goes in the numerator, remember, of our formula for the beta 1 regression coefficient. You multiply y minus y bar by x minus x bar. Well, you just calculated y minus y bar in G, x minus x bar in H. So to multiply them, all we're doing is we're saying G2 times H2. Bingo, you get an answer. Copy that formula all the way down. So that's how we get y minus y bar times x minus x bar. Then what you want to do is you want to sum all those up. And so I'm doing that in this little table here. And so in order to do this, what you type into the formula bar is equals sum, open parentheses, close parentheses, and then in the middle of those parentheses, you select all the cells that you want to sum over. In our case, we want to sum from I2 to I21 because this is y minus y bar times x minus x bar. And here you can see up here under R, we get the numerator for the formula for our regression coefficient. Next, you want to get, you want to square x minus x bar because that goes in the denominator. Remember, this is the sum of squares. So I've done that here in column J. All I'm doing here in column J is I'm saying take, I'm saying equal x minus x bar, which is column H, so for this observation H2 times H2 times itself, right? That's raising it to the power of 2. Pull the formula down, bang, you got it. Just in case you're interested, you could also do it this way, equals power, click on H2, comma, and the power you want to raise it to, we're squaring it, so the number 2, close paren, and bingo, you got it. The same result. Okay, so now we want for the denominator in our formula for the regression coefficient, right? We're summing that, the sum of squares, so that's what I'm doing here in R4. I'm just typing in equals sum, and then you can see this highlighting here. I'm summing over J2 to J121. So now I got my numerator and my denominator, so this regression coefficient here, beta 1 regression coefficient, is just equal to cell R3, which is the sum of y minus y bar times x minus x bar, divided by the sum of squares of x's, as you can see in the formula here on the slide. And we get, that's where that result of $806.43 comes from. Now the y-intercept, now that you have all that information, real simple to calculate. Remember the y-intercept, beta naught, is equal to the mean of y minus the regression coefficient we just calculated, beta 1, times the mean of x. So we got our mean of y here. We got our mean of x here, right? The y bar mean, the x bar mean. So the beta 1 intercept is equal to the mean of y. What's the mean of y? It's right there, R1, minus our beta 1 regression coefficient times the mean of x, right there, right? So there you go. You got your beta naught intercept of $1,044.65. Okay, so that takes care of calculating the regression coefficient beta 1 and the y-intercept beta naught. Now remember I told you in number 3 we can also calculate the predicted value of y for each observation in our sample, right? And so that is what I'm doing over here in column K where it says predicted y hat, just because that's how it's referred to in the formula. I'm calling it y hat. And so what I'm doing here is we're saying what is our regression line predicting for this each individual patient given their known value of x in column C. And remember the formula for that? It's beta naught, the intercept, plus the regression coefficient, beta 1, times the individual x value for that individual. So in the formula here, this is what I'm doing. Let me type it in here. So we're looking at the y-intercept, and I put the little dollar signs in because that always stays the same, so we always want to reference it. Plus, and then we put inside of the brackets the regression coefficient, which I'm going to put dollar signs around because you want to hold that fixed, times the individual value of x for this patient, in this case patient 1, with a length of stay of 1. Alright, let me go back here. Times here, C2. Alright, so the predicted y hat is the intercept plus the regression coefficient times the actual value of patient 1. Got that formula up there? Gives you predicted y hat. And now you just want to copy that down for everyone. What is going on here? All right, so even your instructor has to troubleshoot sometimes, right? We don't want to reference R58. So we want to reference R5, which is the beta 1 regression coefficient. So there was an error in the formula there that I just fixed. The main thing, though, what I told you is correct. You want to, in that formula, it's the intercept plus, which is in R6, plus the beta 1 regression coefficient in R5 times the individual value of x. Then when you copy that down, you get these predicted y hat values. And you can see that in column K here, that they're the same for everybody who has the same length of stay in column 1, which is what you would expect because our regression model is predicting charges based on length of stay. So we got this predicted value of y. Our next step is we want to calculate the error, right? And remember the error, we're doing that here in column L, is just y minus y hat. The actual value of their charges minus our predicted value of the charges that we just did. And so that's simple math, right? That is equal to the actual charges right here in C2 for this patient, or B2 for this patient, minus the predicted charges that we just calculated in K2, which gives us the error here. You copy that formula down all the way to the bottom, and now we got the error. So we've made it through these first 4 steps of calculating our regression values. Okay, so the next step, if you remember, is calculating the r squared. And so let me go to that slide so that we have the formula on hand here. And so if you remember, the r squared is equal to the regression sum squared divided by the total sum squared. So the first step is calculating the total sum squared, which is the sum of squares of y, right? So I'm doing that here in cell Q8, where you can see I have my mouse clicked here. And so in order to do that, what you want to do is subtract the mean of y, which I'm referring to as y bar, from the actual value of y and squaring it. So I'm doing that here in column M. Remember, we already got the value, the actual value of y here, which are the charges. In column B, we got the mean of y right here. Now, and we actually already calculated y minus y bar because that went into the calculation of our regression. Remember, we did that in column G, so these all kind of build on themselves. Now in column M, all we're doing is squaring y minus y bar. So you can see the formula I've used here. Simply, you go to G2 times G2 to square it, or you could use that power formula I showed you earlier. Copy all these down, and you got y minus y bar. The total sum of squares, SST, is simply equal to the sum. So you type in equals sum, and remember in brackets you want to put your cursor in there and select y minus y bar squared. You're summing up all those squares, you get a huge number. So the next thing you calculate is your regression sum of squares, right? And in order to do that, the formula is, remember the regression sum of squares, you're subtracting the mean of y from y hat, which is the predicted value of y. So we calculated the predicted value of y here in column K. We already have y bar, the mean of y. So we want y hat minus y bar squared. So I'm doing that here in column N. So this formula looks complicated, but let me walk you through it. What I'm doing here is I'm using the formula, I'm combining 2 steps into one. What I'm in the center of this formula, I am subtracting the mean of y from the predicted value of y, and then I'm using the power function to square it. So let me see. Let me show you how I would do that. So remember, you type equals power, and you in the power function you put the number and then comma and the power. In our case, we're going to do power of 2. But what inside of this function, this is like a function within a function, basically. You may or may not want to do it this way, but you can combine 2 steps into one. So inside the function, you're going to put 2 additional parentheses, right? You got parentheses inside of parentheses. In the middle parentheses, what we're doing is you want to go to the predicted value of y hat, which is, we calculated that here in column K, so in this case for this patient 1, K2, minus the mean value of y, which is y bar over here in cell R1. Now remember, you want to put the little dollar signs in there to hold it on R1. So that's our y hat minus y bar, right? Now we also have this power function here, so we can square it while we're at it. So you put the column, or you put the comma after what is inside of that first set of parentheses and the number 2, and that's telling you to raise the result, to square the result, raise it to the power of 2. Hit enter, and there you go. You got your result. You copy it all the way down, and you now have y hat minus y bar squared. So to get the regression sum of squares, remember, you just want to sum that. So you type into the formula here equals sum, and then inside the parentheses you just select all the cells that we just computed for y hat minus y bar squared, and that gives you your regression sum of squares. Lastly, while we're at it, because we're going to need it later, let's calculate the SSE. Remember, this is your error sum of squares. This is the distance between the true value of y and y hat, squared and then summed. Well, remember, we already calculated an error in column L here, right? This is just the difference between our true value of y in column B and then our predicted value of y hat in column K. So we already got that. So our next step would be to create this column O where we square it, right? So all I'm doing here is saying y minus y hat squared, so multiply it by itself in this cell O2, L2 times O2, copy that all the way down. Bingo, you got y minus y hat squared. Okay, so the next step that you want to do is simply sum that, right? You're summing the error. And so you type sum into the formula just like I did before, up here, and then you select all these columns of O and sum it. Okay, we're done playing with the columns, but you can see how these each build on one another. So now to calculate the R squared, remember, that's just the regression sum of squares divided by the total sum of squares. So that's equal to our SSR here divided by SST, and we get an R squared of 0.78. Okay, so the next thing we would want to do is calculate an F statistic for the overall regression. And remember, the F statistic here is the mean squared on the regression divided by the mean squared error, right? And the MSR, mean squared regression, is just equal to the regression sum of squares divided by 1. MSE is equal to the error sum of squares divided by n minus 2. So you can see here under Q how I'm calculating MSR. I put the formula in there, and it is equal to SSR, which is R9 divided by 1. Divided by 1 it is the same thing as these regression sum of squares. The mean squared error, what I'm doing is I'm taking the sum of squared error and dividing that by n minus 2. Well, n is our sample size. We have 20 patients. Minus 2 is 18, so we're dividing it by 18, and you get that result there of 972,000. So the F statistic then is simple. Once you have the MSR and the MSE, you just divide, your numerator is MSR divided by the denominator MSE, because the F statistic is a ratio, 63.2. If you looked up in your table, you'd see the critical value of F. At our degrees of freedom here that we triangulate on the table are 1 and 18, and because 18 is for n minus 2, the critical value is 4. Our F ratio is huge, so we reject the null hypothesis. So next and last, we want to calculate a t-statistic. Remember, the t-statistic is on the PowerPoint slide number 5 here. It's the beta 1 coefficient that we've already calculated divided by the standard error of beta 1. And so what is left for us to do is to calculate the standard error of beta 1. You can see the formula here. And so, but we've actually already done most of this. We've calculated the mean squared error, and we've also calculated the sum of squares around our independent variable x. So we just need to plug that into a numerator and denominator and take the square root, right? And so in order to set up the beta 1 standard error, I've done it in these 3 cells here. And so the first cell, which is Q17, I'm setting up the numerator, which is the mean squared error, and we've already calculated that, so I'm just making it equal to this cell up here. It's just to, you know, I know I'm copying the same thing, but it helps to do this just to keep your thinking straight on what's being divided by what, right? So that's the numerator. The denominator for the beta 1 standard error is the sum of squares for x, right? The sum of x minus x bar squared. Well, guess what? We already did that up here, Q4, for calculating the denominator of our beta 1 regression coefficient, right? And so all we do is we make this denominator for our beta 1 standard error equal to what we've already calculated up here in R4. Got our denominator. So now we want to calculate the beta 1 standard error. And that is simply the square root of this numerator and denominator. So what you do is you type in equals SQRT, which is the square root function in Excel, open and close paren. And in that open and close parentheses, you want to take the numerator here, divided by the denominator here, and that will give you the beta 1 standard error. So now calculating the t-statistic is simple. We already have beta 1, we divide it by the standard error. So this is what I'm doing here, right? Beta 1 equals R5. We already calculated that. It's our regression coefficient divided by the standard error of beta 1 that we just calculated, gives us a t-statistic of 7.95, which, as you're familiar with the t-table now, you know that's quite large, and that's gonna, you know, where you're gonna reject the null hypothesis at almost any alpha value for that. Here we would have a 2-sided alpha value. Say it was 0.05, our critical value would be 2.1, so it's much larger than that. So we reject the null hypothesis. And with that, we've worked through all of the regression formulas from the first 2 lectures. So happy regressing.